Can you see the PPT?
Yes.
Okay. So last class we were going through the techniques that will be used in epidemiology. We saw the definition of epidemiology, the three components which we will study in epidemiology, the frequency, the distribution, and determinants. We saw the approach, that is by asking questions and making comparisons. We also learned that why the comparison is required, what is the relevance of having two population, because it simply makes our study more genuine, more valid, more correct. And all the questions, the questions that we have to ask, it will be all the WH questions. So we get to know about, when we are going to mention all these things, we get to know about the agent or the thing that which causes the disease, the host, his nature, and the conducive environment. I think now it is from this portion we have to start. The tools of measurement that is used in epidemiology. So we saw the techniques, what we are going to learn. We learned what we are going to learn, the frequency, the distribution, and also about the determinants. We'll learn the methods later, but now we need certain calculations or what we call as tools. So that tools in epidemiology are three terms actually: the rate, ratio, and proportion. So all of this, it will be having a numerator and denominator. Whenever we are doing some epidemiology, the calculation, if it is not a calculation that we have to make, uh, like sometimes there may be problems coming in epidemiology. Usually problems can be asked, and then we have to put the value and make a calculation. Uh, Otherwise, excuse me. We have to make the calculations, and or it will be available online, whatever it is, it depends upon what we are going to search. So it will be having a numerator, a denominator, and a multiplier usually. So what will be the numerator? Numerator, it will be some number of events in a population during a specified time. We'll see when we go to the examples, you'll see what it indicates. So numerator will be always what we are going to measure. Some numbers it will be of some events. It can be a death, or it can be due to some, or even birth. It can be about a disability or accidents or number of pregnancies, anything. Some number is going to be the numerator, and denominator will be always population, almost always population. It can be total population, it can be mid-year population, or population at risk. This numerator and denominator in general will be these things, but it will be varying. More of such, it will be the denominator pattern that will be varying, and accordingly, each concept will change. So we'll go through what is rate, ratio, and proportion. So in case of rate, for example, why we need rate? If you are being told that the number of road traffic accidents that happen in Selangor is 500, someone is saying you, uh, this number, this is actually like an absolute number. They are saying you it is 500. But when we hear this 500, it is not enough for us. We need to know 500 among what is the denominator, like uh, in how much number these accidents are taking place, like how many vehicles are there. That can be one denominator, number of accidents, that is 500 per the total number of vehicles that is being on the road, or total number of people that is being driven or driving on the road. So we need that comparison also, not the comparison like a something to compare upon. Then only we will understand what is the actual magnitude of that thing. If just we get the total number, oh, we get to know the people or the death rate, not the death rate. Number of people who died due to AIDS in Malaysia is 10. So it doesn't say anything much. This 10 in what time period? If it is of 1 month, 2 month, 1 year, we don't get to know. It also doesn't say us what is the age group of the people who have died. It also doesn't say us what is the population. Or if it is 10, and somewhere it is told that the population, like not population, the death rate due to AIDS in Malaysia is 10. I suppose AIDS in Malaysia should be less when compared to AIDS in India. So in India, when we are taking the number, we are just saying that in India due to HIV is suppose 11. Uh, when we get that number, it is so confusing. Why it is 10 in Malaysia or 11 in India, where we expect such a disparity? That is not seen over there. They are close numbers. So we need to know that denominator on what basis we have done. So if it is says 10 in comparison to a large number of population or a less number of population, we get to know like in Malaysia it is 10 per 1 lakh people, 10 per 1 lakh or 100,000. That is actually the death rate. And in India, it is 11 per 100 people or 1,000 people. So that shows what is that wide gap. When we just hear in single numbers or the absolute numbers, we don't understand what is the exact magnitude because it's just absolute number. We need to know what is the other number or the denominator to compare. So in Malaysia, we get to know that 10 is happening per 100,000 population. So that is comparatively lesser when we say in India, that 11 is out of 100. So in 100,000, that should be increasing. Have to put that much zeros after to 11, which shows there is a wide disparity in the rate of the mortality due to HIV in Malaysia and in India. So to make a comparison, we always need to know to what we are comparing it upon or what is the denominator. And that is why in case of epidemiology, we can't use or we can't rely on absolute numbers, but we have to go towards the rate. So this is used as absolute numbers are not of much use for an epidemiologist. It measures the occurrence of some specific event in a population during a given time period. So we can calculate a mortality rate or a death rate, or it can be a birth rate. So for mortality rate, it will be total number of deaths in 1 year. Usually, in case of epidemiology, unless it is specifically mentioned, the time period we usually take is 1 year. Usually, otherwise they have to mention what is the time period. If it is not mentioned, usually that time period is considered as 1 year. So if you have to say, even the example that I told you, that is not complete in one sense because I didn't mention what is that death rate or in which time period it is. So we have to complete that sentence, then only we will understand. So and here another important point is the numerator is a component of denominator. So whatever we are putting in as numerator, that will be a part of denominator. For example, total number of deaths in 1 year. So we are saying about mortality rate, where there is total number of the number of people who are dying in 1 year divided by mid-year population. So that numerator consists of people who have died. And this number, the numerator, is actually a part of that denominator. The population, the mid-year population, the people who died were those belonging to that population. Those people, the numerator, what we are mentioning, they didn't come from the space or somewhere else. That is actually a part of the denominator. And why we give this sentence importance is usually MCQ can be asked from the one of the value that we have rate, ratio, and proportion. So rate and proportion are actually a part of the denominator. The numerator is actually a part of the denominator. But in case of ratio, numerator and denominator are not related. I mean, the numerator is not a part of denominator. So because of that difference, MCQs can be asked. That is why I put that in a specific color. So I hope you got. So this will be the number of event, the numerator. We will mention a time period. Then we will give the denominator, which is always population. So that here it is a mid-year population. And then we have a multiplier. It can be 1,000. Usually 1,000 is used, but it can be 10,000, 100,000. Okay, 100,000 is maximum what we go. And why we use that multiplier is because of our convenience or to avoid decimals. If it is a very small number, it may come like 0.0001 divided by 100 or something like that. So just to avoid that decimals, we increase the zero from the other part, like 100 will become 100,000 something. So we can reduce that decimal from the numerator. So that is the reason why we use 1,000 or the multiplier. It can be 10,000 or 100,000, depends upon our convenience. But when we are putting that multiplier, we should be very sure when we are converting that decimals. Otherwise, then idea will be completely changing. You made the denominator 1,000 into 100,000, but if you had not changed the decimal points from the numerator, as like in mathematics, it will be giving a completely wrong idea. So that we should be sure of. So the elements always will be these four things. And why mid-year population? So the population size changes daily due to birth, death, and migration. And hence the mid-year population is commonly chosen as a denominator. Suppose someone is asking you what is the death rate of Malaysia in 2022. We can't calculate of 2023 because it's going on. So we calculate what is the number of deaths that have happened in the whole year, and that is divided by the total population. So there will be a confusion where to take this total population. Either we can take the total population in Malaysia on January 1st, 2022, or we can take a total population of Malaysia on December 31st, 2022. That should be the denominator. But because of these things, that every day there will be birth, death, migration, everything. Whenever we have a confusion, like either both the extreme we have to go. All human beings, we will be going for towards the average. Okay, then we go for the average or the mid value. And that is how even the epidemiologists decided that they won't go for the January 1st number, the total population, or even the December 31st, because it will be the two extremes. So better go for the mid-year population. So that mid-year population, epidemiologists universally decided it will be the population that is existing or that is seen on 1st July of an year. This also can be asked as a MCQ. So rates, there are three types. There are crude rates, specific rates, and standardized rates. Crude rates are also called as unstandardized rates, and it is actually the observed rates, such as birth rate and death rate, like what we told over here. This one, death or mortality rate, we call it as crude death rate or crude mortality rate. Similarly, we can call it also crude birth rate. Okay, birth rate, we don't need any much explanation, but death rate, crude death rate, when we are saying, it doesn't give us much information. We get to know what is the total number of death that is happening in Malaysia in a particular population. That's it. We will never get to know from that number, from that crude death rate, what is the death rate among boys and girls separately, or males and females separately. We won't get to know what is the death rate among different age groups, like if it is between 0 to 10 years, or the death rate among adults from 20 to 60 years, we won't get to know like that specific value. Even if you want to know among that death rate, for example, in Malaysia, the death rate, suppose it is 6 per 10,000. In case that if I'm just saying you it is the crude death rate, you can never say out of that 6 death how many people died due to some diseases, or due to accidents, or due to old age, usually as a old age mechanism. We'll get never get to know those things. It will be just the complete death rate, or not an absolute value, but we get to know the number of the death that generally happened, not anything specific underneath that. So this is actually not of much value, but still when we are writing, now you will be starting the research methodology and you will be going for a research project. So maybe you're going to take a disease, and then you are going to mention about it on that. So when you're mentioning about the country, of course you have to explain all the things in that epidemiological part, how and where this disease is being found. So when you're going to say, like for compare the tuberculosis that is happening in Malaysia and also India, you are going to compare how it is affecting the two different populations. So before you go to tuberculosis and all those things, you need to compare the health status of the people or a community of Malaysia and India in general. So you need to know initially, or you need to point out what is the death rate of that particular country. So we get to know what is the health status of a particular community. So that is the importance. We need to start from somewhere, and it is usually the crude death rate we get, and that will be very easily available also. We just Google, we get the value. It may not be that easy to get other values. For example, the specific rates, as I already told, this will be the observed rates due to some specific causes, like tuberculosis or occurring in specific group. Example, age, sex groups, or during specific time period. So when it is specifically mentioning, it will be the specific rates. And then we have standardized rates. This is a little complicated than the other two. Standardized rates like this, the same example I can say of Malaysia and India. You're going to study that. And then you have been told that the death rate in Malaysia among the age group 1 to 10 is a particular number, like X, for example. And then you are told the death rate of the same condition in India among the age group 40 to 50 is a particular number. So these numbers, the two numbers, you cannot compare. Of course, both are giving the death rates, both are giving the death rates of same disease, but the age group given is different. In one example, in Malaysia, I told it is between 0 to 10 years. That happened because of that disease among 1 to 10 years or 0 to 10 years. And then the next example in India, I gave the death rate that is happening between 40 to 50 years. You cannot compare these things because the immunity varies, or it depends upon the disease also, what type of disease it is. So never you can compare just by that number, like how we are going to compare, whether one is lesser or one is more, we can never compare. So when there is no uniformity between the two population we are going to compare, epidemiologists use a little more complicated thing which is called as standardized rates. So by some mechanisms or some techniques, we will be making a standard population and then we will be comparing that. So we can use the direct method and indirect method for this standardization. It can be done for age, different age groups, different sex. Like in Malaysia, for the above example, I told you the death rate among the females. And in India, I'm giving you the number or the death rates because of the same condition in males. Then also you can't compare. So in those way, and then this comparison can also be done among the different races, like among African and American, because the ethnicity as it changes, the lifestyle changes, so there will be wide variation among this also. So whenever there is no comparability between two population, then we do something by direct or indirect method of standardization to bring a uniformity and then compare the numbers. So these are the three categories of rates: the crude rate, the specific rates, and the standardized rates. We go to the second tool, that is ratio. Ratio, it measures the relationship of size of two random quantities. Here, as I told already, numerator is not a component of denominator. And ratio is always x is to y or x by y. Example can be sex ratio, doctor population ratio. So sex ratio will be population. So how many number of females are there per thousand population? I was planning to Google it, but I forgot. I'm very sorry. But I can say about India. India, the female number is very less when compared to the thousand number of males. It is 960 per thousand. So not all the males are having a female counterpart, not exactly, but that's the sex ratio. So here, the male and female, it is not, we put it as male is to female or X is to Y, and that is not a part of the denominator. So doctor population ratio, according to WHO, it should be 1 is to 500. That is, for every 500 people, there should be one doctor. And in Malaysia, it is better. As on 2020, it is 1 is to 454. Then another example is the ratio when we say WBC is to RBC. So that is 1 is to 600. When you go for the total number also, RBC count is in millions, the total number of RBC. It is in case of mm, generally in females 4.5 to 5, and males can be up to 5.5, I think. So that will be in millions per cubic mm of blood, but WBC, it will be just thousands, from 4,000 to 10,000. That's the number. So when we are going to take a ratio, it will be 1 is to 600 or 1 by 600. And here the numerator is not a part of the denominator. They are just showing what is their size in relationship in size, but not a part of the denominator. Then we go for the third, that is proportion. Proportion from the mathematics itself, usually it will be expressed in percentage. So the multiplier will be usually into 100. It won't be 1,000, 10,000, etc. We'll be usually expressing it as a percentage. So here it indicates the relation in magnitude of a part of a whole, like out of 100 percentage, how many proportion is males. So 50 percentage is males and 50 percentage is females. So that is a proportion where the multiplier usually will be in hundreds, or we express it in percentage. Numerator also is always a part of denominator. So it's only the ratio where the numerator is not a part of denominator. In case of rate and proportion, both the numerator are part of denominator. And in rate, it can be, the multiply can be 100, 1,000, 10,000, or 1 lakh or 100,000. And in case of ratio will be always keeping it as is to 1 is to 2 is to whatever be the number. And in proportion will be always using the multiplier 100, so that we put that number, the final number, in percentage. So what are the measurements? So these are the three tools, and the measurements in epidemiology. Uh, I'm very sorry. I had a typing error. So in epidemiology, there are a lot of measurements that we are using, but I have mentioned only four over here, four most important. But in epidemiology, we will be giving more importance only to the first two. So we have the measurements of mortality, where we will be studying about the death rate. One death rate we saw the crude death rate. Another one also we saw the specific death rate. Measurement of morbidity. Morbidity means the disease condition. Mortality means the death has happened, and morbidity like who are deceased. It says about the morbid condition. And the measurements that we use over there is incidence and the prevalence. Then we have measurement of disability, where we use the concept of DALI and CALI, where DALI is disability adjusted life year and CALI is quality adjusted life year. We won't be getting into these details. And measurement of natality. Natality means birth or fertility. So we have the birth rate, GFR, GFR which is the general fertility rate, and TFR, total fertility rate. So these are the different measurements in epidemiology, and I also already told not only these, there are a lot others, but mostly the most four important ones will be these four, and we will be studying in detail only about mortality and morbidity. I think in your next semester, you need to do a chapter in demography. And when we are doing demography, because it is about the population, then we need to learn about fertility. So at that time, we will see fertility. I'm not sure whether we will be dealing with disability, because this is a somewhat difficult calculation. Only concept we learn what is about the disability. So going towards mortality rates, we have five important one: the crude death rate, specific death rates, two of it we have already discussed. Then we have case fatality rate, proportional mortality rate, survival rate. Uh, and now itself I say you for the exam, I may not be asking you all these questions because this is just for you people to know what are these things when you're going to read the research papers. I know some of you will be very much aware of all these things, but some may be not. That is why I have to say. Uh, so you just need to know the term and what it means. That's it. You don't have to get to know every each detail or whatever. So in detail, you don't have to by heart the formula. Nothing. So crude death rate. If we go for the definition, in these parts, in this section of epidemiology, is going to be very, very interesting. So better we go for the formula actually, that will be more easily comprehensible. However, crude death rate, it indicates the number of deaths occurring during the year per thousand population and estimated at mid-year, the mid-year population. So in other words, it will be as simple as number of deaths that happened in 1 year in a particular population divided by the mid-year population or the population on July 1st of that particular year, and it is multiplied by 1000. We discussed it earlier. So the specific death rate, when we need to know the about the etiology or the people who are affected. So we go for specific death rate then, like it can be cause or disease specific, like due to tuberculosis. How many number of people died due to tuberculosis, cancer, road traffic accidents? Or it can be related to specific groups. What is the death rate that happened in children between 0 to 5 years or between 10 to 20 years, like that. When we are going for age specific, or it can be sex specific, like the death rate among females and among males. It can be age and sex specific, where we are going for both together, like the death rate among girls, um, among adolescent girls, that is from 10 year to 19 years. So like that, we can make the death rate more specific. The crude death rate, as I already told you, just Google, we will get the number, but the specific death rates are not that easily available. We have to go, when you have to mention this specific death rate, You have to read through the literature. There will be some articles where it have been mentioned, or maybe you have to go into um, the site for the Malaysian health statistics website. There would be, and from there you have to search it out. Or sometimes you may have to calculate also. It depends upon what you are going to study and whether it's data available or not. Anyway, this is very useful because we are going to specify. This is not as broad like crude death rate. This is giving more specificity. So specific death rate due to tuberculosis will be number of death from tuberculosis during a calendar year or 1 year over the specified period divided by mid-year population and the multiplier as usual 1000. Then there is case fatality rate. This one is actually used in case of some epidemic disease or a acute infectious disease that is going on. It indicates the total number of deaths due to a particular disease divided by total number of cases due to same disease. And here the multiplier is actually 100, which means we are going to say it in percentage. So that is the difference of case fatality rate with others. Though we say it as a rate, it is actually a proportion we are doing actually, because we are going to say it in percentage. And case fatality rate is usually used for acute infectious disease like food poisoning, cholera, measles, etc. Or in case of COVID-19, if you remember case fatality rate at that time, they will be doing like every day or maybe 1 week, they will be calculating what is the total number of cases. So the people that are affected because of the disease divided by the number of death that happened due to that particular disease. So that gives the case fatality rate. So here notice the denominator actually. In case of crude death rate and the specific death rate, the denominator we used was the general population, the mid-year population. That was the denominator. But here we changed the denominator. Denominator became the people who are having the disease, the cases, the number of cases, not the whole population, but the cases. So it became more and more furnished one, you can say like that. So among the people who are deceased, how many people died? That is what case fatality rate indicates. Or fatality means the how much danger it is, or it represents the killing power or virulence of a disease. So that is the importance of case fatality rate. Here the time interval is not specified. Why we don't specify is it's usually used for an acute infectious disease. So we are not going to calculate how many that occurred due to cholera in 1 year. In case of case fatality rate, we are not going to do it in 1 year and all. It depends upon the time period in which cholera was existing. Maybe it was existing in a particular year from um, May to July, May, June, July. Yeah. So only 3 months. In case other case, I told you that usually if we don't mention the time period, we take it as 1 year. But here, because we are studying about some acute disease, it depends upon how long the duration of that particular disease is. So it can be 3 months, it can be 3 weeks, it can be even 3 days. It just depends on that. That is why the time interval is not specified. We can never say. It depends upon that time period until when the disease was existing. So that is case fatality rate. Then we have proportional mortality rate. Proportional mortality rate can be under 5 proportionate mortality rate, or the mortality rate for age 50 years and above. Like that it will go. So proportional mortality rate expresses the number of death due to a particular cause or in a specific age group per 100 or even 1000. Thus we have the proportional mortality rate, number of death from the specific disease in a year. So this disease can be even tuberculosis or HIV, divided by total deaths from all causes in that year, and the multiplier can be 100, it can be even 1000. The multiplier is not a varying here. but not the denominator. When we go for the numerator is actually same as like what we told in the specific death rate. In the specific death rate also, we had the numerator, number of death from TB or any disease during a calendar year. HIV or whatever in a year divided by, in case of specific death rate, we gave the denominator as mid-year population because we are going to give the death rate. So it was number of death per population. But now we are going to say about the proportion. So among those deaths, how many deaths were due to tuberculosis? That's the idea over here. That is the term proportional mortality rate means. So here the denominator is not the mid-year population, but the total deaths that happened from all causes in that year. So the numerator and denominator change over here. That is why I told you it depends upon what we are calculating, what we are saying. According to that, in epidemiology, numerator and denominator changes. And that is quite confusing actually if you don't have a good grasp on that concept. So in case of, I hope you understood the difference. In case of proportional mortality rate, we are going to find out among the total people who died in Malaysia in that specific time period, how many died because of tuberculosis. That is, we are going to do in proportional mortality rate. But in specific, we are just going to say how many people of the total people or the total population in Malaysia, they died due to TB. That becomes the specific mortality rate. So according to the numerator and denominator, the concept also changes, or the other way around. According to the concept, the numerator and denominator will change. So likewise, under 5 proportionate mortality rate is also the number of death that is occurring under 5 years. Divided by, we are not taking the mid-year population, but the total number of death during the same period. Out of that death, we are going to find out what is the proportion of the under 5. Then of people above 50 years. Then also we are going to say number of death of persons age 50 years and above divided by total deaths. And that is multiplied into 100 or 1000. Then another type of death rate is survival rate. And here it is usually described in cases of cancer or some very serious disease where the survival rate of the people will be very less. So if you are going to say it in a formula, it will be total number of patients alive after 5 years divided by total number of patients diagnosed or treated into 100. So here also we are going to say it in terms of percentage. Now this term you might have, we might have discussed already in PM whenever we say the survival rate. Usually we'll be using it in cancer conditions. So we'll be saying that maybe the cancer, lung cancer, once the person has reached the 4th stage of cancer, we'll be saying the survival rate is very less, maybe 5% or 10%, which indicates the person is not going to survive for a long time. That's the crude meaning. But how we calculate is by this formula. Total number of patients alive after 5 years. They have just given the span of 5 years, which indicates the disease we are mentioning about is very serious one. Or it can cause a death, but not like the acute infectious, but more of a chronic condition. Cancer, that will be the best example. Total number of patients diagnosed or treated into 100. That gives the survival rate. So these are the death rates, the crude death rate, the specific death rate, the case fatality rate, the proportional mortality rate, and the survival rate. If you remember the first two, that is the crude death rate and specific death rate, that itself will do. But because we may deal with the term case fatality rate also, understand what is that used for the acute infectious disease, and there is no time period, and we get to know what is the virulence or the killing power of the disease and the numerator and denominator. Now going towards the measurement of morbidity. So the earlier one, it was indicating the death. Now we are going to indicate illness. So for example, when you're going to write a research paper, you are reading a research paper and it is about tuberculosis. So initially you give the death rate. What is the general or the crude death rate? And then you go for people dying due to tuberculosis in a particular age group. Gender. So that goes for the specific death rate. And in case of tuberculosis, we are not expecting a case fatality rate, so we can just avoid that. We may go for a survival rate, yes, because it's a killing disease, so we can go for a survival rate. And then when we finish that part of that article, then or the paper, then we have to mention. So we already mentioned about the death. Now we have to say how many people are living with tuberculosis. So when that mentioning comes about, the people who are living with tuberculosis, that is actually the measurement of morbidity, or it indicates illness. So it measures people who were or are ill. They may be ill or they may be having tuberculosis but got cured, but the people who are currently having tuberculosis. It also indicates the illnesses or periods or spells of illness that these persons experience. For example, if you are going to learn about some disease which is having a periodicity or different spells like bronchial asthma, you are going to study about bronchial asthma. And if you know about bronchial asthma, you will be knowing that the patients who are having bronchial asthma, it is not that every day they are having bronchial asthma, or the asthmatic complaints. They don't have that. They will be having a series of appearance or spells, we can say. So maybe in January, they had it for 1 week. And then February, there is no spells. And in March, again, it came for 3 or 4 days, and then it goes on like that. So that is a disease in which there is a recurrence or a spells will be coming up. So when we are learning about the morbidity, we can measure that also, how many spells that disease is having. Then the duration, for how long they are suffering, in days, weeks, etc. So this three things we can get to know when we do the measurement of morbidity. And here we uses the two terms, or to calculate morbidity, we use the two very common terms, incidence and prevalence. And I hope, because in practice of medicine, we have always used that term. I mean, whenever you started learning a disease, you would be learning these terms, incidence and prevalence. So this shouldn't be a new concept for you. But still, to make you remember, in case of incidence, it is the new cases that is occurring in a defined population during a specified period of time. So number of new cases that is happening divided by population at risk during that period per thousand. Here the multiplier is 1000. Not that, because in prevalence when we go, the multiplier changes. Multiplier in case of prevalence can be 100. So prevalence we can say it in percentage, but not incidence. So incidence, it is always about new cases. So someone is asking you, what is the incidence of tuberculosis in 2022? So that indicates you are going to say about the number of people who acquired tuberculosis in the year 2022. They may not have had it earlier. They were newly infected or newly diagnosed with tuberculosis in that particular year. So it includes only those people who were newly diagnosed. But uh, that may also, if you're going to say about the prevalence, I mean, okay, we'll get to the later. So incidence, which means new cases. The incidence of HIV in 2022 means all the people who were diagnosed to have HIV newly in that particular year. There may be some people who were diagnosed in 2021. We shouldn't, and even in 2022, they are having HIV, but we don't include them in incidence. Incidence is completely about new. How many people were newly added in that particular time period? So definitely when we say new cases, it have to indicate a time period. Then only we can differentiate it properly. So all the number of new cases of a specific disease during a given time period divided by population at risk. Here we are not taking the mid-year population and all. We are just considering the population at risk, which usually will be the total population. And sometimes total population we can go for the mid-year population, or sometimes in actually calculations, if there is calculations or problem questions which is being asked for the exam, they may be giving out of 5,000 people who are at risk or the total population, um, there were uh, 5 cases that were newly infected of that disease. So then our population at risk will become 5,000. So like that, it will change. It can be mid-year population or the total population at risk. And when we say population at risk, it actually has got a very confined meaning also, or a very restricted meaning. Suppose we are going to measure about um, number of people, I mean, the incidence of cancer cervix. So we are going to study about the incidence of cancer cervix, which means from the population at risk, because we are going to learn about cancer cervix, we don't have to include the male population in the denominator because they don't have cervix. We don't have to study them. So it will be just the female population. And among the female population also, we don't have to study about those women in whom hysterectomy has been done because they don't have the total hysterectomy is done, means there is no cervix in them also. So even though they are female, they are not at the risk of developing CA cervix. So population at risk means those people who have the chances of developing that disease. So you have to be very careful when you're mentioning what is the numerator over there. As like I told you, if it is a cancer cervix, the denominator should be those women who are having a cervix or uterus or whatever. That should be the denominator. It shouldn't be the total females or even the total population. But if you are going to say about the incidence of tuberculosis, this can happen across the ages, across the genders. Then the population will be including the total population. So it depends upon what actually you are learning and who are more subjected to those diseases. According to that, the denominator also changes. That is what the importance of population at risk, why we don't use mid-year population casually, and why we use population at risk. What is the relevance of that? That's what I told you here. So if it is just confusing, forget about it, the denominator. But at least you remember incidence means it will be the new cases. So from the above definition, incidence means we are measuring only the new cases during a given period, that is usually 1 year, and in a specified population or population at risk. Then we have some special incidence rates like attack rate or called as case rate, secondary attack rate, hospital admission rate, and there are some other terms also. I'm not going into that details, incidence density, etc. I'm not getting into that. So in case of attack rate, this is expressed in percentage. Uh, that is number of new cases of a specified disease during a specified interval time divided by total population at risk during the same interval into 100. This I just kept, as I already told you, I'm not going to ask you all these formulas and all, don't worry about it, but you just need to understand what these terms mean. So earlier in the case of mortality rate, we learned the term CFR. that is the case fatality rate, where we study the number of death among number of cases. Here, in attack rate, there is another name, that is case rate. Only the term fatality is missing over here. So, in epidemiology, usually they will be using these confusing terms especially in exams, to make the students get confused. So, someone who doesn't know there is a second name for attack rate, that is case rate, and in the question paper you see the case rate is, and you don't understand it is the attack rate they are mentioning about. In epidemiology there are a lot number of such synonyms that is used. So if you don't understand attack rate and case rate are same, and you believe because you know that there is case fatality rate, you may be thinking, or we may be, I mean, when if I am also a student and if we are not sure about it, we may think, or maybe the question paper had a printing mistake. The word fatality got missed somewhere, or it got deleted, and we assume it has to be case fatality rate, and we do our own calculation. So understand the difference. One is saying about the death rate actually, the case fatality rate, the term fatality, which indicates the death rate. And here the attack rate can be also case rate, and that is about the incidence, the morbidity. The persons have not died here, they have just developed the disease. So understand that difference. That is why I put it over here. I'm not going to ask you any questions, I still say. So attack rate is equal to number of new cases, the new cases. So it is incidence we are mentioning about, morbidity we are mentioning about, not the death. So this is usually expressed in percentage, because in incidence rate we have seen that the multiplier is usually 1000. Per 1000 was the multiplier of this. Incidence is usually put in per 1000. But in case of attack rate, we express usually in percentage. And this is used only during epidemics. Like case fatality rate, this is also used only during epidemics, but in very acute infectious disease. But the other one was mentioning about the death, and this one, attack rate, is mentioning about how many people are getting newly infected. So what are the uses of incidence rate? If we get to know the incidence rate, we can take the measurements to control the disease. We can learn about the etiology, the pathogenesis, the distribution, and efficacy of preventive and therapeutic measures. We get to know that incidence rate is such a high value. Then we take some controlling measures, and then after a while, we are going to follow up. What is the incidence rate now? Is the number of cases decreasing or increasing? So if it is increasing, even after the control measure, if it is increasing, you understand the controlling measure you have adopted is not working. You have to change the plan. And when you say about the incidence, the new cases, we are going to say, we will of course have to explain it, which people are affected, which age group is affected, which gender is affected, the socioeconomic factor, the occupational nature of those persons. So in a way, we get to know about the etiology of the disease, the pathogenesis or distribution. Now, the second concept in case of morbidity is prevalence. And here we are going to include all the current cases, old and new. So that is the difference between incidence and prevalence. Incidence is completely new cases, and prevalence will be existing cases, all the old and new cases. So if we again go to the previous example that I was mentioning under incidence, if you are asked the question, how many or what is the incidence of tuberculosis in 2022 in Malaysia, then you are going to say about the new people or the number of new people who were infected with tuberculosis in that particular year in 2022. You are not going to include the people who were diagnosed with uh, tuberculosis before to 2022. Maybe there may be people who diagnosed tuberculosis in the year 2021, 2020, or 2010 since then. So in case of incidence, you are going to consider only those people who were diagnosed in that particular year as tuberculosis. You are not going to include the people who are having still TB, but they were diagnosed in 2021 or 2020 or anything, any year previously. But in case of prevalence, when you say the prevalence of tuberculosis is 82 percentage or whatever, then that number includes all the people who are having tuberculosis in that particular year, not just the new cases, but the old existing cases also. So prevalence, they are of two types, the point prevalence and period prevalence. Unless specifically mentioned, whenever we say prevalence, we are indicating, or what we are meaning is point prevalence. If it is period prevalence that we are saying, it will be specifically mentioned, the period prevalence. So point prevalence will be, as the term indicates, at a particular point of time. And period prevalence will be like incidence during a duration of time. Like for example, something very simple that I used to memorize this thing for myself in the initial period, that was suppose today someone is asking you what is the incidence. Just suppose that it is not the midday, now it is actually 12 o'clock midnight of 17th July. Just imagine that. So someone else, or like I am asking you, what is the incidence of tuberculosis on this particular day? There may not be any cases, no new cases that has been diagnosed with tuberculosis on this particular day. You can't give a new case on a particular point of time in incidence. But if you are asked like, what is the prevalence of tuberculosis today? Of course, you can give a number because there will be some people who were diagnosed yesterday. So you will have a number. So in case of prevalence, we can have a point of time. During that point of time, can be zero also. Okay, yeah, very rarely can be zero also, depends on the disease. But mostly at a particular point of time, when you are asked what is the prevalence of tuberculosis on this day or that particular point, there will be at least some number to say, but not in case of incidence. So in case of incidence, we always have to say like a duration. If you are asked, if I change the question and I ask you what is the incidence of tuberculosis last week, then of course there is a time period, so there will be some number, maybe at least one case have been diagnosed. So you can have that. So in case of incidence and period prevalence, to say a number, forget the thing that it can be zero also, but generally we are saying about some disease, one or the other person can be in the world will be newly diagnosed, or they will be having an existing disease. So existing disease, we can say, or the prevalence, we can say at a particular point of time. Even now I ask you, what is the prevalence of tuberculosis now? You can say a number. But if I ask you, what is the incidence today of tuberculosis? There may not be a number also. So always remember that thing. In prevalence, we can have that point of time, a particular point of time. But in incidence and period prevalence, we have to keep a slight duration. It can be 1 year or it can be any specified time, 1 week or whatever. But unless we specifically mention, always that time period is 1 year. So point prevalence, it is the number of all current cases, old and new, at one point in time, divided by estimated population or population at risk in the same point of time. And here the multiplier is 100. We can say prevalence always in percentage. So now if you Google or you take any disease um, in the practice of medicine or SPM text, whichever, or any article, you can see the incidence will always be given per thousand population. Like the incidence of tuberculosis is 0.8 per thousand population. But when it mentions prevalence, prevalence will be always given in percentage. So that's the difference between incidence and prevalence. Period prevalence, as I already told you, this is very less commonly used. Whenever we say prevalence, we indicate or we mean point prevalence. We don't specifically mention point prevalence. But if it is period prevalence, we have to mention it correctly, that the period prevalence is. But mostly what we use is point prevalence. So period prevalence means number of existing cases, old and new, of a specific disease during a given period of time, and estimated mid-year or mid-interval population, whatever be the duration that we are giving it. And that is also multiplied by 100. Now, this is a work that we can do, a kind of activity. I need you to unmute yourself and give me the answer. So, these are the questions. So, we'll start with the first one. So, you see these dots that circles, it indicates cases. So, in total, we have 8 cases. So some of the cases have started before to January 1. We don't know which is this year. We don't that is happening. Anyway, we are saying about one particular year started from January 1st to December 31st. We see that some cases have started before to that January 1st, and we see that some cases have started after to December 31st. And we also see that some of the cases have actually started in one particular year at some duration, and it is extending to the next year. So this is the total scenario. And now we'll go incidence. Incidence would include, incidence means number of new cases, and according to the definition, we told that it should be of a annual duration. So we assume the incidence should be from January 1st to December 31st. I want you to say, and each question by each person, okay? It's not like one or two person will answer all the questions, but one person. Start with the first question. Incidence will be, which are the cases or the incidence of that particular case from January 1st to December 31st. Please give me the answers.
Can it be case
Which one?
if it's in the same horizontal line, it's different case. Different case. Okay, never mind. I thought of something, then I wanted to say the answer. Now I don't know.
Just say me. January 1st to December 31st incident. No, wait. I'll come one by one. Anyway, we know game, so we know you say. Only 4 questions further. One of you will be missing the chance, but never mind. Yeah, we know you continue. What will be the incidents? Or which are the incidents? Say me the case now. A case 1, 2, 3, or whatever. What is the incidents?
1 to 7.
So once again.
1, 2, and 7.
Incidents. Incidents should be new cases.
Okay, 1, 2, 3.
In case of 1, 2, 3, this one started before to January 1. So it become like we are, incidence means we have to concentrate on those cases that started from January 1st. Don't come because this happened somewhere before to January 1st. We can't include case 1.
Sorry, Dr. Nivel, just now voice was breaking. So you say it started before June.
Huh.
Okay, I mean before Jan 1st is the case 1, case 2, case 7, right?
Once again, Vinod.
Before Jan 1 means case 1, case 2, and case 7.
Before January 1st, it won't come in incidents. Incidents should be new cases that is appearing from January 1st to December 31st.
Okay, so case 3, case 4, case 5, case 8.
Yes. So that is the incidence. And the second person, who was the other person who was talking? Lenny or Yitling, who was that?
Yeah, yeah.
Yeah.
Lenny
Who is
here. Yeah.
answering? Who is answering me now?
Lenny.
Okay. So you go for the second question, the point prevalence on January 1st.
12.
Hmm?
Is it 12? The point?
12.
Because you're asking for the prevalence, right? The incidence, multiply
The second
the
question, the
duration.
second question, the point prevalence on January
Yeah, yeah.
1st.
I take the formula as incident times disease duration. Is it?
Which means
So it's 1 times the whole duration is 12 months, right? So I have case 1 in January. So 1 case times 12 months. So it's 12, is it? Did
oh
I
no,
read the chat? Sorry.
I'm not asking for the whole cases. You don't have to give me a whole cases because we mentioned the time period, January 1st. So we need to know only those people who are having the disease. It can include the new and the old one on January 1st. We don't have to go towards the whole duration. We are not going to the duration. We're just concentrating on January 1st. What is the prevalence?
Is it the case 1?
Case 1, yes.
So it's 1. I don't get your point. Is it not to calculate the prevalence in total, but referring to the
You
point?
don't have to. You don't have to calculate prevalence. We have a formula also. Don't have to calculate. Which you just need to say among these 8 cases on January 1st, who all are having the diseases? How
Oh,
many
one
are
two
in total?
seven.
One,
Is
two.
it one? So 127.
Yes, that's it. That's it. One, two,
Oh,
seven.
okay, okay. I got your question now.
I understood that you
I'm
have gone to the
calculating. I'm,
total calculation, the
yeah,
density
yeah.
and all.
I'm calculating. I'm
Yeah,
calculating.
for 12 months. That's why I told you don't go into that formula. Just simple thing. Uh, so the next person, the point prevalence on December 31st. Someone else you.
Case
So
case
who is that?
one,
Yitling?
Yitling.
Yeah,
1358.
yeah. Okay. So period prevalence, that is from January to December. Uh, that who is going to answer me? Naim or Alison? Maybe Naim and Alison can answer because that number is very big. So you both can answer. The prevalence, that is the old and new cases between January to December. Alison or Naim, can you answer? Or should I ask someone else to help you?
Uh, Sorry, ma'am. I'm driving, so I'm not
Huh?
clear. I'm still driving now. I'm at the Unify Mart store, so I cannot clearly hear you say.
Oh, Naim is driving.
Okay. Whenever I'm taking class, he's driving always. Okay, fine. So anyone else who would answer?
Okay, I try.
Hmm? Who is
All
that?
except Yitling.
Yeah,
Is it all cases except the 6?
except 6. Yes, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, yes, it's correct because 6 becomes an incidence for the next year actually. Uh, okay, so all the cases except 6. So I hope you have got the idea about the incidence and prevalence. Incidence means only the new cases, prevalence means new and old cases. Prevalence, we can always say at a particular point of time. Say one day, you can give the prevalence. There will be one case. If it is a common case, or common disease, there will be at least one patient on one particular day. But incidence, we may not be able to say what is the number of cases, because here you can see there is no something like point incidence. They didn't ask you. So incidence will always be the new cases during a duration of period, and prevalence will be all the existing cases. It can be old, it can be new, and that can be a particular point, or it can be a period prevalence also. So even though incidence and prevalence, we were saying about January 1st to December 31st, you know the differences what happened here. Because in incidence, we didn't count this case 1, case 2, and case 7. But when it is period prevalence from January and December, it goes according to the concept. Prevalence should include all the past cases also, all the previous or old diseases also, and hence in period prevalence, this case 1, 2, and 7 was added. So you have the answers over here also. Then we have a formula to calculate incidence and prevalence. What Lenny was saying, it's a more difficult calculation, which will go exactly into the epidemiology, and I'm not going into that. It will be um, with a table, or more or less this figure, and it will be calculated like how many months they will be having the disease, and then making a calculation like that. I'm not getting into that details. Just understand the basic thing. So I know, Lenny, that now you know a lot of this. I know, but not your friends. So we are not going into much detail about it,
Yeah,
epidemiology. Just
my
just
apology, my apology.
just the basic things. So prevalence is equal to incidence into duration of disease, or P equal to I into D. Very simple formula. There is a short form of PID or PID, pelvic inflammatory disease. So that is how I remember this formula, P equal to I into D. So prevalence is equal to incidence into duration of disease. So if we make for the logic also, we'll understand prevalence means it should be the old and new cases. So incidence, it will give the new cases, and D, it gives us the duration for how long the patient is affected of this disease. So prevalence, the simple formula will be incidence into duration. So if we get if we in a formal, I mean in a problem, if we get something like incidence is given, that is 10 cases per 1000 per year, and duration is equal to 5 years, we can make the prevalence. That will be 5 into 10, which is actually 50 percentage it will be. So yes, 5 into 10, 50 percentage, then that a calculation we can do. So in problems, usually they may give incidence and duration to calculate prevalence, or just prevalence will be given and the duration, and then we can calculate the incidence or somewhat. I mean, from this formula itself, we can do something. But I just showed you what is the importance of that. Usually, rather than calculating, the questions will be like, if the duration of the disease is increasing, what is happening with the prevalence? Like that, the MCQ will be asking. So here, P equal to I into D. So if we use the mathematical application over there, this is actually a linear relationship, or a directly proportional. So if duration is increasing, obviously P also should be increasing. If I is increasing or incidence is increasing, P also should be increasing. So usually from this formula, rather than calculation of something, MCQs will be asked. If D is increasing or duration of a disease is increasing, what is happening with prevalence? Similar questions can be asked. That's why I kept this formula. So in case of prevalence, we get to know about the magnitude of a health or disease problem. Uh, what is how it has been affecting, like when we say a particular disease, diabetes mellitus, the type 2. the prevalence of that disease is about 30 percentage. So you understand, out of 100, 30 people are affected of diabetes mellitus. So that gives a magnitude, and sometimes it can be as small as 2 percentage in case of some disease. So you understand, only 2 people are affected. So that shows the magnitude of that particular disease in a particular population, and it is also helpful uh, for administrative and planning purposes. Example, hospital bed, manpower needs, rehabilitation facilities, etc. So for example, um, in our hospital, I mean the college where I studied, for chickenpox, actually, there is only Ayurvedic or homeopathic treatment usually being done. Allopathic, they give some medicine, but it is viral disease. So they can give some antipyretic and some vitamin tablets, that's all. So usually in Kerala or in India generally, they go for really a natural way of treatment, either Ayurvedic or homeopathic. So we had a specific ward for patients who are having chickenpox, which is like an isolated ward. So all the people at a particular time when I was studying over there was an epidemic of chickenpox. So though it is spreading, we had an isolated ward, and only uh, special doctors were kept for on duty on those days to go to that particular ward, and they were not allowed to go to any other ward at that time. So some arrangements will be made. So for that, we need to know the hospital beds. So if we know, in case we use that as a particular ward when there was a chickenpox epidemic. But when there is no epidemic, we don't have to spare our beds for that purpose. Likewise, a disease which is having 30 or 40 percentage prevalence, we need to set aside more beds for them rather than for a disease which is having a prevalence of only 1 percentage or 2 percentage. So for all that planning, administration things, etc., we need to know how much that disease is prevalent or existing in the society. So this is something like we saw the iceberg phenomenon in epidemiology. Likewise, this is another common picture or image that is used in epidemiology, which is called as epidemiologist's bathtub. It indicates the incidence and prevalence, its relation in a diagram. So you can see some cases are existing, and that is actually the prevalence. It can be the new and old. The new cases or the new water that is coming up, the droplets coming from the pipe, the new one, that is the incidence. And from this prevalence, there can be two ways of reducing the prevalence. Either there should be an increased mortality, or there should be an increased cure rate. In that manner, the prevalence can be reduced. And out of this cured people, some may go for a recurrence also, if that disease is having a recurrent phase. So this is called as a epidemiologist bathtub, which indicates the relation of incidence and prevalence. So the two methods to reduce prevalence is either, I mean, not method actually, two ways by which the prevalence is reduced is either if the disease is very dangerous and there is high mortality, so more and more people, even though they are getting infected, they are dying, means the prevalence is reducing, uh, or the people should go cured from that condition. And that disease shouldn't be having much recurrence. Now, the epidemiological methods of studies. So we went through the tools, um, the rate, ratio, proportion. We understood the difference. Then we went to the mortality rate. We saw the crude death rate, the specific death rate, the case fatality rate, survival rate, and also the proportional mortality rate. We saw what is the difference, especially between the specific death rate and the proportional mortality rate. It is the denominator that is changing. And then we went to the morbidity, incidence, and prevalence. Incidence the special type of incidence also, and it is about the new cases, and always the multiplier will be 1000. But in case of prevalence, it is of two type. When we say prevalence, it is actually the point prevalence we are mentioning about, and it includes all the existing cases, all the new cases, and old cases. And this prevalence will be always set in percentage. So now we go to the, having learned about the measurements, the tools that we use, now we go to the studies. What are the techniques that we use or the studies? So epidemiological studies basically classified into observational studies and experimental studies. So this is in short. This is also mentioning about the different studies we are going to learn, and this also gives us a clue what we are going to, or what we already covered in this chapter, and what we are going to deal with it, deal more. So epidemiological methods or the studies, it is classified into two: observational and experimental. Observational studies or experimental studies. So observational studies is some, in the previous class I told you, we are just going to observe. We are not going to do anything. We are not going to give any medicine or nothing. We are just going to observe, take a group of people and then observe them. We are not interfering with anything, just observation. So in experimental, usually we are going to interfere. We are going to give them some medicine or some vaccination or some health education. Even health education is considered as an experimental method because we are intervening. So that becomes an experimental one. So epidemiological method, we make a broad classification. In one, we are not interfering, we are not intervening, we are just observing that group of people. But that is called as observational studies. And then we have the experimental studies where we are going to intervene or we are going to interfere. And now we have the specific classification. The observational study is divided into two: the descriptive epidemiology and analytical epidemiology. So the descriptive and the analytical. And we go for the descriptive epidemiology. Descriptive means we are going to describe the disease. So some of it we have already done, the descriptive epidemiology. That is the first part. We get to know about the frequency, the distribution of the diseases. So here we study about the frequency and distribution. And it is in the analytical epidemiology we are going to learn about the determinants. So in the study of frequency, we studied about the frequency of death and also frequency of disease. The frequency of death, we learned about the rates, the ratio, the proportion. Then we saw the frequency of disease, incidence, the prevalence. Incidence classified again into attack rate, secondary attack rate, prevalence to periodic, and point prevalence. So this section we have done with descriptive epidemiology. The second section we have to deal is the distribution, how the disease is distributed. So the distribution we will be studying under three categories mainly: the distribution among the people or the population. So according to the age, sex, occupation, according to the time, and time, it is again subclassified into short term, periodic, long term. Again, some classification will be coming over there, which we'll see in coming up slides. And according to the place, and place can be international variation, national variation, rural, urban variation, and local variations. So we have done up to this part, the study of frequency. Now we'll go towards the study of distribution. After that, we'll go for the analytical epidemiology. What are these studies? The cross-sectional case control cohort study. Some of you may be knowing, some of you may not. I'll be not getting into that much details. Only the main thing that you should know when we say this disease, what are the preliminary things or the basic things you should know. Only that I'll be discussing over here. And then a little bit about the experimental studies also. So this is another type of flowchart where it is classified whether we are having an exposure or not. So we have the observational study and experimental study based on the exposure. If there is no exposure, we are going to have a observational study. If there is an exposure, and the researcher is going to assign that. What is this meaning? I will say you later when we are going to learn those studies. Mm, okay, this one we'll do later. Now we will concentrate on the descriptive study itself. So according to our definition of epidemiology, we saw that we are going to learn three things. One is about the disease frequency, the distribution of disease, and also determinants. That's what we learned in the definition of epidemiology. So the disease frequency, as indicated in the picture, we learned it via rate, ratio, proportion. That is about the death and diseases by incidence and prevalence. And now we go to the distribution. And when we do this too, what we do is actually descriptive epidemiology, and that gives us a hypothesis regarding the origin of the disease. And when we are going to test that, whether the hypothesis is correct or not, then it is called as the analytical studies. So underneath the analytical studies comes the case control, cohort study, etc. So descriptive epidemiology, we are going to study to understand the magnitude of the disease, the type of disease, the etiology. We get to know about the hypothesis, as I already told you, when you're going to mention about which population is affected, which duration, which time period this is seen, somewhere, somehow, we get to know the etiology, how this disease is originating. So we can do the planning, organization, and evaluation of preventive and curative services. Just a casualty, a repetition. So now we are going to, having studied about the frequency, we are going for the distribution, the time, place, and person distribution. Starting with the time distribution, the pattern of disease can be described by the time of its occurrence. That is by week, month, year, day, hour of onset, etc. It depends upon which disease we are studying. It raises question whether the disease is seasonal in occurrence, whether it shows periodic increase or decrease, or whether it follows a consistent time trend. Because when you learn, now you connect it with the various diseases that you learn, you can also see the same thing. Sometimes we can say that certain diseases, it is more commonly seen in specific seasons, like allergic rhinitis. Usually it will be seen in spring season. Then mm, then the fever or the infectious disease which is caused by mosquitoes, like dengue, chikungunya, etc. These will be increased during late summer period and early rainy season, especially that weather which is favoring the mosquito breeding time. So we learned that, or we studied that a particular disease. Now, when we go to practice of medicine, we take one disease. We say that this disease is seen in this particular season. All that came up in practice of medicine because the epidemiologists studied about this disease when it was newly introduced or whatever. They studied about that particular age group, particular season, and that's how they got to know. So according to the time or the time trend, we have three types. One, short-term fluctuation, second, periodic fluctuation, and third one is long-term or secular trends. So short-term fluctuations is usually used to mention about the epidemic disease. The best example for short-term fluctuation is the occurrence of an epidemic. So epidemic, now you know something, a disease that is happening in excess. It can be in a particular population or in a particular group or a particular time period. Any excess number of cases. And when I say excess number, it means sometimes that cases may be happening in very small numbers daily, and then there is a sudden increase of that number. There can be an epidemic. And it also can be like that. There was no one, such cases, and then a new case is coming up. One case, even one case, like polio. Polio is a disease that is being in a path of getting eradicated, almost in the process of eradication in different parts of the world. Currently, I think it is existing in Pakistan and Afghanistan, cases of polio. In all other countries, since years, there is no cases of polio. So in Malaysia, suppose tomorrow a case of polio is diagnosed, then also it is considered as an epidemic, because there was zero cases until all these years. We have to refer Google to see which was the last time or the last case that appeared with polio in case of Malaysia. Imagine that might have happened in 2000 something. I'm just saying your example, okay? And in all these 23 years, there is not even one single case of polio. And tomorrow, if one single case is arising, even that is considered as an epidemic. But in case, it is a chickenpox. I don't know about chickenpox also. This also I'm saying you just an example. So, but I suppose there may be some cases of chickenpox that is happening every day. So maybe just imagine every week the cases of chickenpox reported or the incidences actually for that particular week. Generally, in Malaysia is 5 cases every week, 5 new cases. But next week, if that 5 is becoming 10, then also it is not much. But if it is going to be 15 or 20, which is a sudden increase, then it is considered as an epidemic. So anything that is going excess. And that excess, how we determine, it usually depends upon what is the condition of that particular disease earlier. So sometimes it can be 0 cases for years and even one is appearing, that is considered as an epidemic. Sometimes 5 to 10 is considered normal, but if it is a surge, and usually it is considered as epidemic if it is more than 2 standard deviation. If what is usually seen plus 2 standard deviation, it is increased, then that is considered as an epidemic. So it varies actually. Anyway, epidemic is something that is happening in excess of normal expectancy. Normally, what we are expecting, if it is happening excess of that, it can be a disease, it can be even death rate, anything. So, 3 types of epidemics are the common source epidemic, propagated epidemic, or slow or modern epidemic. So, common source epidemic means from a single source. The epidemic have developed. So, this can be a single exposure or point source epidemic, again divided into. And second one, it can be continuous or multiple exposure. That also may be a single or a common exposure, but continuously it has been exposed. We'll go through the example, then you will understand. Or it can be propagated. Propagated, as the term indicates, from one person to another, it is propagating. And it can be slow or modern epidemics. The current epidemic, the CVD, the cardiovascular disease, the diabetes mellitus, stroke, cancer, etc., obesity, all those lifestyle diseases, which are actually an epidemic. We are not understanding that because it is having a long incubation period. But it is actually increasing in number. So that is also considered as a epidemic, a slow epidemic. So we start with the common source epidemic. So common source epidemic means it can be a single exposure. Just once the exposure had happened. This common source, it can be a single exposure or it can be multiple or continuous exposure. That are the 2 classification. So in the common source, if it is a single exposure or a point source epidemic, here the exposure to the disease agent is brief, essentially simultaneous within one incubation period. This you will understand if I say you an example. For example, you all went for a party. Like you finish your BHMS or whatever, and you decided to go for a party, and you all went for a party. And suppose you had a food poisoning in that restaurant. God forbid, but still, because the food poisoning is always the very best example to explain this condition. So the source of infection is that particular restaurant, and that is a single restaurant. That is a point source. That is the point source. One particular restaurant. You all had that infection from that particular or at that point source. And the exposure was very brief. It was not that you were having food from there every day. It's just one time you went there, and it was a brief exposure, like that event you or the party you went or a marriage reception you're going. So the exposure was for a small period of time, a brief period, and it was simultaneous. Like all of those you got infected almost the same time. There may be a variation of 1 hour something, but not like 1 week. You all went there and you got the food poisoning. Most of you, like on a Tuesday, you went mostly by Tuesday night or midnight itself, almost all of you are going to develop some symptoms. If you are all susceptible, this depends on your susceptibility also. But if you are going to keep susceptibility as a control factor over here, with that considering that you are going to be infected, all 5 of you, then probably by Wednesday morning at least, all of you are going to produce some symptoms. So the symptoms or the cases that develop will be almost simultaneous. It won't be that 4 of you develop the symptoms on Wednesday and another person develop the symptoms next Wednesday. It is not that possible. So 5 of you got infected, and that will be almost simultaneous, which also means within that one incubation period. So if the food poisoning is happening within hours, usually it should be staphylococcus poisoning. Usually it happens within 4 hours, 4 to 6 hours. So within that incubation period should happen. Likewise, I told you, it's not possible that you get the infection 1 week, 2 week later. Then this one was not the reason, the restaurant. So these are the features of the common source epidemic in which there is a single exposure. So there is a one point, a point source epidemic. There is a single exposure. Once only you got exposed, and that exposure that was very brief, and all the cases occurred in the same incubation period or within one incubation period and almost simultaneously. So the best example will be a case of food poisoning. Then we can draw the epidemics using certain curves, and that we call as epidemic curve. It is a graph of time distribution of epidemic cases. So when we study some disease, we actually know whether it's a point source or common source. But if it is actually a new disease like COVID-19, the epidemiologists might have plotted like this: when are the cases that is appearing, and then they classify which epidemic curve it belongs to. So point source, this will be the point source. The trend, you can see it will be crossing this way. Uh, I hope you can see. So which means there is an increase and decrease. So there is a all the cases. These are all the cases. All the cases are seen in during a particular period, that incubation period. After to that, there is a stability, or it is coming to the base value. So the cases, all the cases are concentrated during that particular incubation period. That is point source. And then we have the continuous source. So continuous, you can see there is no particular peak and then coming down. It is actually going like this. Then there is a short gap when there is not much cases, not as much like the previous, but there are cases. It has not touched the baseline yet. And then it again peaks, it comes down, it again peaks, but it is never coming down. It never coming down to the base. It is going on like a continuous one. So we'll see the continuous one. Here also the source will be a common one, but a repeated or continuous exposure is there. So for example, a contaminated well, a well which is having contaminated water. So it is a possibility that because it is a well and that is the only source of water, we took the water from the morning, the next morning, the next morning. So we are continuously getting exposed. It is the common source itself, like the reception. Here also there is a common source, but in case of food poisoning or the reception, it was only once it happened, and then we got infected. But in this case, there is a continuous exposure. There is one common source, that is the well itself, But here the people are continuously using it, so they're getting exposed continuously. So sometimes the exposure from the same source may be prolonged, can be continuous, repeated, or intermittent, and not necessarily at the same time or place also. Here, epidemics tend to be more extended or more irregular. That is, it will not be finishing in one incubation period because there is a continuous exposure. The second example will be in case of a prostitute or a sexual worker rather. It may be a common source in gonorrhea outbreak or any STD, but as she will infect her clients over a period of time, there may be no explosive rise in the number of cases. So we won't see sudden increase in the number as like we saw in case of food poisoning, but there is a continuous increase of cases. So that is why here we have the continuous sources. It is not, we can never say during the one incubation period because from the source it is going on spread to another people. And the example will be cholera, a familiar example. The epidemic reaches a sharp peak and then tails off gradually over a long period of time. Then we have the second category of that is, so we did the common source epidemic under the short-term fluctuation, the single exposure and the continuous. Now we are going to the second subcategory, the propagated epidemics. So it can be from person to person or via an arthropod or animal reservoir. Arthropod will be the mosquito-borne diseases, malaria, etc., or any other animal reservoir like brucellosis or any animal that can produce a disease. Propagated epidemics, this is also more of infectious in origin. There will be a gradual rise and tails over much longer period of time. This will be transmitted person to person, arthropod or animal reservoir. Example will be epidemics of hepatitis A and polio. So if we go for the graph, in case of a propagated source, so we start with a baseline. Some number was already there. And then suppose it is hepatitis A, like in a particular period, some people got infected. Now, there will be a gap when there is no cases, which includes, which means from this person, this can be a disease that is transmitted from person to person. So just imagine it is person to person transmitted. So chickenpox. Chickenpox will be a very simple example to say. So there was a very small cases, but somehow in a family, two persons got infected of chickenpox, and now this chickenpox will be transmitted to other person, and there will be a gap, and that gap is usually some people are infected, and now like initially 1 or 2% may be infected or maybe just one person infected in a area, and now in case of chickenpox people have to deal with that, or from that person it has to be transmitted. And then the incubation period of chickenpox is around 2 weeks, around 10 to 14 days. So this person is having chickenpox, maybe the day and in case of chickenpox the person will be infective even before he had developed symptoms. So even before he had transmitted the virus to other person in the family or in the neighborhood, whatever, but that other person will be developing chickenpox only after 10 to 14 days. In that 10 to 14 days, this primary case, this person, he will be cured of chickenpox. So we don't see any new cases until this incubation period is covered. And once it happened, which means there will be a short gap where there are no cases because this has to be transmitted and incubation period will be there. So there will be a short gap when there are no cases, and then it will be increasing. It will then it will be spreading like a fire. Like in this time itself, when the person was infected, he had given the disease to many. The initial gap is taking for the incubation period for every person. And now then it will be going on like a propagation, the nuclear fission fusion, what we say, it will be going on increasing, and this will be having much more increased cases and tailing off, or it is going to decrease after a very long time. So that is the difference between continuous and propagated. Continuous, there is no stoppage, it is not coming to the baseline because there will be some of the other cases. And propagated, it will be from person to person, so there will be some time gap. Because it is person to person, it depends upon when is the infective period of the person and how much incubation period is for that disease. So that is the difference between these two graphs. And intermittent source, we are not discussing anyway, but you understand there is a phase, then there is no, then there is a phase, then there is no cases. That is intermittent source. So in case of propagated epidemic, the transmission continues until the number of susceptibles are depleted or susceptible individuals are no longer exposed to infected persons or intermediary vectors, which means the sentence seems to be too complicated, but it's very simple. How long this transmission will continue? The transmission will continue under two cases. One, as long as there are increased number of susceptibles. So the chickenpox is going on, and um, how many number of people who are susceptible to those diseases that is increased, all those will be having the diseases. So imagine a area in there are 500 people, or we'll reduce the number, 50 people are there, and the chickenpox have appeared over there. And among that 50 people, maybe in the childhood, 20 people have developed chickenpox. So we don't expect chickenpox to come again once again in their life, because it's usually a lifetime infection. However, the second infection in case of chickenpox, if it happens, we call it as herpes zoster. It's not chickenpox, it is herpes zoster. So we are assuming that 20 people, because they have had chickenpox in their earlier life, they are not going to develop chickenpox in now, or they don't have the risk of developing chickenpox now. We are going to forget the condition herpes zoster for a while, okay? We're just assuming that these 20 people are not going to get infected. So those people, and 10 may be by birth or something, or due to their immunity, there's particular constitution. 10 may be highly immunized, not they didn't take any vaccination, but their body is highly resistive against chickenpox. So out of the 50, 30 are now going to develop chickenpox. So the chickenpox transmission in that particular population will reduce once the other 20, because 30 are not getting infected, other 20, they get the chickenpox and they get cured. Until then, the transmission will be there. So that is the meaning. The transmission continues until the number of susceptibles are there, or it is reducing. And once the susceptible individuals are no longer exposed to the infected persons or intermediary vectors, then also it will stop. So the first condition is we wait until all the 20 people in that particular area getting infected, or we can do something like, we know that 20 people are going to are having susceptibility to this disease. So stop its exposure, like isolate these patients who are having chickenpox, and don't allow the people to mix with the other one. So then also we can stop that transmission. This is exactly what we did in case of COVID. So the breakdown, the lockdown was brought up so that we break that transmission, the susceptible people. And in case of COVID-19, it was like all the people are susceptible except for the small kids. They were somehow immunized. I don't know how, but we heard very less cases among them. It was mostly the adults and the old age people who were mostly getting affected, the comorbid people. However, the main intention was, so because all of us were susceptible, then the lockdown was brought up so that that communication or that our exposure to the persons infected are reduced. So the transmission in case of propagated epidemic can happen until the susceptibles are depleted, like all are getting diseased and either they are dying or they are getting cured and that, thereby developing the immunity, or susceptible individuals are no longer exposed to infected persons or intermediary vectors. The transmission is closed either by isolation or separating or quarantine or whatever. The speed of spread depends upon herd immunity. So this can be also done by herd immunity, like if a lot of people are getting vaccinated. So even the vaccinated people, they can uh, act as a obstacle to stop this transmission also. So the speed of the spread of the propagated epidemic, it depends upon herd immunity. Like in COVID, when it come earlier, there was no herd immunity. A lot of people were getting infected. Many of them were dying. But now we can't say that COVID has vanished from the world. It is still happening somewhere. The cases are appearing, but it is not becoming a serious one because most of the people, they have developed the immunity either by having the disease or by vaccination, or a lot of people like that immunity somehow developed in each and everyone or majority of us. So the speed of spread of COVID-19 and the last one is the slow or the modern epidemics, what we say about the chronic diseases or the lifestyle diseases. Now, the second category is periodic fluctuations, but I am stopping over here. So the time distribution, this is the short-term fluctuations that we have done. And we have to do the periodic and long-term. That we'll do next week. Can someone please take a screenshot if you haven't taken a screenshot? Done?
Any taking screenshot, is it?
Yeah, I'm taking screenshot, but you all want to on camera. Did Dr. Mira want to off the record? Not because some don't want to be appeared on the record.
Oh, you want me to off the record? Okay.
Yeah. Can we see my eyebrow?